Hey everyone, this is Ryan with the homesteadconsultant.com. Today I'm going to be doing a video on a total water installation that I did. It's going to be a little bit more following the process of the installation with a lot of hidden gems, nuggets, and bits of information that are going to be really important if you want to put your own system together. However, it's going to be a little bit longer and more rambling than some of my other videos because of the format of it. So if that's not the format you like and you're not looking for a whole bunch of information that you can kind of digest throughout a video, go ahead and watch one of my other videos. I have lots of great content that's a lot shorter, but this one's going to be a little bit long because of that. Here is a water system that I've just finished installing. We're taking water off the roof of the shed, and it's coming through this downspout diverter. I'll show you the insides of that near the end of the video so you can see what that looks like, the name of it, everything else, where to order it, things like that. But that is a high throughput diverter that has a filter inside. So inside of it, there's a filter that allows the vast majority of the water to come down the diverter side, and then any debris gets pushed off and then run down the downspout. This system is running water underground into the tank and then filling the tank from underneath, which means that it needs to be a closed system going up the side here. So you can see I've got a pipe within a pipe here. This is a 4-inch pipe over a 3-inch pipe. That 3-inch pipe actually has insulation on it as well as a heat tape. And that's what this extra pipe next to it is. It's a cover for the conduit for the electrical, for the heat pipe there, and then the heat pipe goes down underground, or heat tape goes down underground up into this pipe, and this is just a weather protective and aesthetic cover for it. So this line runs underground through here, and there is a T underground that goes this way. Inside of this is a 2-valve system that will allow me to drain the downspouts in the event of a hard freeze. So they are insulated and heated, so in a light freeze they'll be fine just left as they are, but in a hard freeze we want to be able to drain them. So what I've done is set the system up so that I can turn the line for the tank off. So right now it's off, so the water stops here and the tank can stay full. And then what I can do is put my little leg on like that, turn that valve on, and that's going to drain that downspout and the downspout on that corner so that there's no standing water in them. So now I'm going to turn the tank back on so that it's connected to the downspouts again. And then I've got a leg coming off of that. That's going to go in and to the pump, and I'll show you that system in just a minute. But when I disconnect the connection between the tank and the downspouts, the connection between the tank and the pump are still connected and functional. So the next part of the system is the inlet for the tank. That's underground. I buried it. So yeah, it's like right on the side of the tank. So I put a mound of dirt over that to protect it from freezing. And then this is the overflow pipe. It flows out and over. This thing hanging here, I'm going to put a different device on it to make it look a little nicer. But this is actually a gauge for the level of the water. What I did on this drain line is I drilled a small hole here that's big enough to fit the rope that I'm using, but small enough so there's really not a lot of extra opening. If we get a really heavy rain and this fills really fast, this overflow may be overwhelmed and you might see a little bit of water seeping out here, but it shouldn't be much. And then I rounded off all the edges so the rope slides in and out easily. And then I also have a little piece of pipe here that keeps this rope in line on the front of the pipe so it doesn't go off to the side or get twisted. And then inside, you can see what I'm using right now is actually a water bottle. It's half full of water and half empty. So it floats, but it's also heavy enough to pull down as the water level goes down. So that's what we're doing for a gauge for right now. My only concern with this is when it's full, that's going to be hanging down quite a ways, and you could get wind that would wrap it around in some cases. I think that's probably fairly unlikely, but it's a possibility. Otherwise, I'm pretty happy with the result here. This was done with parts on hand, but you could use much nicer parts like an intentional weight here. And there are like buoy floaties for pools that could be put inside that are intended to hold up the lines in pools. Those would be a great option for the inside as well if you wanted something a little bit more professional looking. And as the water fills, that bottle goes up and this line drops. And so I've got different markings. That's half full, that's empty, that's full. So once the tank is full or partially full, we will have water sitting in this pipe consistently. And what that will do is it will allow me to tee off of that. So you can see my 1-inch PVC or 1-inch PEX line off of that, and that runs into the barn. And I'll show you inside the barn so you see how that works. So that's the line coming in on the left. That comes in to a pump here, and this is a shallow well pump. Some people will call them a jet pump. It's a 1 horsepower. It's switchable between 115 volts or 120 nominal and 130 or 140 volts. So I have it set up as a 240 volt system, and it is there's a pressure gauge on it there, and then this device is the pressure switch. So once the switch hits a certain, or once the pressure in the system hits a certain level, it turns the system off. And when the pressure drops back down to a certain point, it turns it on. Usually those are referred to something like a 50-40, meaning at 50 psi it shuts off, and at 40 psi it turns back on and starts pumping again. So I think I said this already, but we've got a check valve back there, just assuring that water can't flow back out to the tank, and to assure that pressure stays consistent to the pump so it's not cycling constantly. So then we've got our line in from the pump and our line out from the pump. That line out from the pump goes through a 2-stage filter system. There's a rough filter and a more fine filter. Those filters help take out any debris that could be getting in from the tank, which there should be very little because of the type of filters we're using. But we put those in anyways just to make sure that the water was as clean as possible. Now that line out from the filters there runs to this connection in the system. So we've got a separate pressure switch that's not actually being used, a pressure gauge, and you can see it's reading about 45 psi right now. And then you can see this valve, so I can shut it off before the pressure tank, and I can shut it off after the pressure tank. That valve's not in a great spot, but I was trying to conserve space in here because this is not in a finished home. It's in a garage, and so this whole area is going to get closed in by an insulated box. And then we're using this. It's called an Easy Heat, and so I can plug a heater into that. And when it gets 38 degrees or less inside this insulated box, that heater will kick in and keep everything up to temp so that we don't have to worry about pipes and other components freezing in here. So from there, we've got the pressure tank, which helps keep the pressure regulated and consistent, as well as keeping the pump from cycling. If the pump cycles too much, it'll burn out. So it has a couple different uses or reasons that we're using it. And then this leg, where I showed there's another valve behind it, then goes outside, and I'll show that section now. So you can see this line coming out. That is the line from the pressure tank, and you can kind of see it underneath the fill line for the tank, and that comes over to here. And this was the end of the plumbing line, so we were using where this hydrant is to tie in. Then I can actually backfeed to all the plumbing from here. So this was the last device in the system, and the line right there goes down, and I met the 3/4 inch PEX line that feeds this. Is this 1-inch line is now teed into that, and then so that will feed this. It will run back. It will feed the bathroom, which is on the other side of this wall. It'll feed back and across, and it'll back feed all the way out to the garden. So one of the benefits to that is now I don't have to trench a line out to the garden. We can just use the existing plumbing to actually backfeed to the systems that we want to use. This is the downspout diverter we're going to be using for this system, and the name of it is the Monjolin Smart Filter Mini. This one is my favorite for a couple of reasons. I think it works better in most applications that we would use it for, and it is reversible, so I can actually turn the thing around, meaning that I'm not subject to using the piping exactly as is, only one direction. So I can turn this around, and this leg can be going that way if needed, which in my case with the build that I'm doing today, I actually need one of each. And some of the older varieties of this were not turnable. So I'm going to show you in the inside and show you how this works. So this is the inside of the filter. The water would be coming from here. This is where you connect your downspout. And then what happens is this is a mesh filter here that as you get more and more rain, it actually sits further and further down. And so more water is able to come through. The more water that comes through the system, the more water, or the more water is able to come through this pipe, which is your discharge pipe, to wherever you're trying to collect the water. And then all the debris that comes through from the top ends up in this filter, and it can't get through, so it eventually just washes through and out here. And then this becomes where you connect your downspout. So the previous downspout, where the previous downspout went, will typically be right here. And so then you pop that downspout off and you move it over to the side, and then send the water down the downspout with this. So this is a 3-inch drain pipe, and it's going to have water in it. It's going to be standing straight up, collecting water from downspout, or as a downspout. And in some cases, water is actually going to build up inside the pipe. We've got a way to drain it down, but just in case it doesn't get drained before a hard freeze, I'm going to use a system that I call a pipe within a pipe. Basically, I'm taking this 3-inch PVC pipe that's going to be inside, or used as a downspout. It's going to go inside a 4-inch PVC. And I'm going to put heat tape on it. This heat tape can be plugged in all the time, and it only turns on when it hits 36 or 38 degrees, depending on the manufacturer. And so I'm going to run that down, and then I'm going to put a thin foam insulation around that. And then I'll slide that all into the 4-inch pipe that's going to go on this system. First, I'm using, this is a foil duct tape. So it's a much higher quality tape that lasts a lot longer and sticks a lot better than standard duct tape. And I'm just using it in a few places to hold this tape, the heat tape, in place. Now that I've got the heat tape in place, I'm going to use this thin foam insulation. This is called sill insulation, or sill sealer. It's for windows, but it's going to work perfect for this because I need insulation on this, but I want it to be as thin as possible so that it still fits in that 4-inch pipe. So now that it's wrapped, I'm going to use this foil tape in several locations as I go up and down, so that when this slides into the 4-inch pipe, we don't get catching of the foam and it holds in place better. This device here is the thermostat, or the thermometer that turns the tape on. Typically you would put that against the pipe that you're trying to keep warm. In this case, there's a couple of reasons I'm not doing that. One, it's not going to fit inside the 4-inch pipe, and it would be underground if I put it on the bottom. So I don't want either of those circumstances. and 2, because I'd actually like it to turn on a little bit before the pipe and the water in the pipe hit that 38, 36 degree, probably more like 36 degree mark. I actually want this to be on anytime that it's close to freezing outside. It's a low wattage device, and the longer it's on before we hit really frigid temps, the more protection we're actually going to have. So I'm going to run this back out on the outside, and I'll show you that when I'm done. And then this is going to be basically open air exposed, so that it's reading the ambient temperature rather than the temperature of the pipe, and it will be on more consistently than if it's placed against the pipe like this. So here's the 4-inch pipe that I'm putting it in. Both these pipes are a thin-walled drain line as opposed to a thick wall or pressure rated. So you can see I have about 6 inches sticking out here, and I have about 6 inches on the bottom. What that's going to allow me to do is fit the proper pipes together. And then on the bottom, this from about here down will be underground. Actually, about this much from here to here will be underground, and that will basically allow the heat tape and everything else to be underground, and then I'll have a conduit that it runs in up, and that will give me a connection point to plug in the cord as needed. Well, I hope that is helpful to you and gave you some insights and some ideas on what you might want to do for your own water systems and your own water catchment. Of course, every system is going to need a little bit of a different design and a little bit different setup. There are lots of different ways to set up water catchment and water distribution systems. So if you have questions, feel free to put those in the comments or look me up on my website, thehomesteadconsultant.com. I would love to help you out with your project and give you some information on ways that you can make it the most effective for your goals and your property. Thanks for watching.